Alright, I have some good news. I figured out the problem with the sound. Unfortunately, I do not have a solution right now. So, the problem is with the program that I'm using. So hopefully I can find a new program to use so that the sound matches up with the visual. But for now, I want you to try to bear with me. And I have a lot of terms today, so I will leave them on the board a little bit extra time because I want you to be able to see the terms and what they mean. Today we're going to be talking about polygons, and the first thing that I want to talk about and review with you is really what a polygon is. There are a couple things that a polygon, a couple properties using what we learned in science of a polygon that have to be true every time. A polygon has to always have straight sides. So for example, this is a polygon. I have 3 straight sides. This is not a polygon. While you could turn it into a basket, it has a curved edge. Polygons cannot have curved edges, or curved sides, excuse me. Another property of a polygon is that it has to be closed. Look at this. This is a polygon because it is closed. I can color the inside of this polygon without any leaking outside because it is closed. This shape, oh, that side does not look very good. This shape right here is not a polygon because if you look, I have an opening right here. If I were to color, some would leak out and it would not be good. So a polygon, I want to review, has to have straight lines. It cannot be curved. Also, a polygon has to have, it has to be closed. It can't be open. So moving forward, I want to talk about a couple features of a polygon that you may have not thought of before. So I'm going to draw this nice quadrilateral right here. And we'll talk about a quadrilateral later. I'm going to circle these. Where 2 sides come together and make a point, that is going to be called a vertex. You may hear me say vertices throughout the video, and vertices is the plural of vertex, so just remember that as I say vertices. Anytime you have sides that meet together, it's going to a point, it's going to make a vertex. Now, I'm going to erase it and draw. I'm going to draw a pentagon now. Because this next term, you're going to have to use what you know about a vertex to understand this next term. The next term is a diagonal. Now, when you make a diagonal, you need to connect 2 vertices. Except the vertices can't be next to each other. Like here. Here's a vertice right here. Here's a vertice right here. I can't really connect those. My side is already there. But if I look at this vertice and this vertex and this vertex, I can connect them. Watch what I do. I draw a line right there. This is my diagonal. Now, some shapes have many different diagonals. So watch what I do here. I can start from the same vertex. I can draw another diagonal to this vertex. Let me erase this arrow here so I can draw some more diagonals. That's all I can draw from this vertex. Well, let's say I move on to this vertex right here. I could draw a diagonal right here, and I can draw a diagonal right here. I'll move on to this vertex. I already have a diagonal drawn there, so I can draw one there. And it looks like I have all my diagonals drawn, because if I look right here, I have that leading there and that leading there. The biggest thing to remember, making a diagonal is not hard. You just have to connect the different vertices, and they have to be vertices that are not next to each other. And you'll find that, like I showed earlier, you can't really make a diagonal with two vertices that are next to each other. I want you to store that for a second here because I'm going to come back to my diagonals, but before I move on, I want to introduce the different names of polygons, and this is where I'm going to really leave it up here as much as I can, so hopefully you can see with the audio. Because different names or different polygons have different names, and in order to name a polygon, you have to count the number of sides. So the first one I'm going to start off with is the triangle. Now, we learned the triangle a long time ago, back in kindergarten. When I taught kindergarten, I taught the triangle. The triangle has 3 sides. And let's see, it looks like I have room to write it over here. This is a triangle. I'll make a little chart to make it easy for you to see. Okay, next we're going to talk about a quadrilateral. I'm going to draw this. This is a special name of a quadrilateral, and we will actually later in our topic, we will actually learn about the different names of quadrilaterals. Same thing with triangles. A quadrilateral will always have 4 sides. Now here's the thing with your polygons that have 4 or more sides. I don't care what the polygon looks like, it's still going to be called that name. If it has 4 sides, it's going to be a quadrilateral. In fact, there are many different quadrilaterals. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I mean, I can draw a lot of different quadrilaterals. If it has 4 sides, it's going to be a quadrilateral. And the same is true as we go through all of these different shapes. If it has 5 sides, it's going to be called, well, what I tell you in just a second. Let me write quadrilateral up here. All right. Now, I mentioned 5 sides. So, a 5-sided shape, no matter how it looks like, as long as it has 5 sides, is called a pentagon. I'm going to draw a pentagon here. I did that earlier when I talked about my diagonals. Your pentagon will have 5 sides. Okay, I'll see if I can let the video catch up here. Okay, let me move my computer screen down a little bit so you can see. The next shape, or excuse me, polygon that we're going to talk about is the hexagon. A hexagon has 6 sides. A hexagon has 6 sides. So while I let the video catch up, I want you to look at this table and we're going to review. A triangle has 3 sides. Quadrilateral has 4 sides. Pentagon has 5 sides. And hexagon has 6 sides. I want to play a little game now. And I'm going to yell out the sides, and I want you to yell out the shape or the polygon. 3 sides. That's right, triangle. 5 sides. Hey, good, pentagon. 4 sides. Oh, I'm sorry, it's a quadrilateral. If you got that right, you're probably thinking, what? I said quadrilateral. 6 sides. Good. Hexagon. Okay, I'm going to erase my... I shouldn't have erased my whole chart because I'll use it. Oh, yeah, it'll be quicker. Alright, we left off with 6 sides. We are going to do 2 more. We're going to talk about an octagon. Now, I'm not very good at drawing the standard octagon. You may remember seeing an octagon at a stop sign. But that is an octagon, and I forgot that I was making a chart, so hopefully this will fit. An octagon has 8 sides. Octagon has 8 sides, and I'll put that up here. All right. Let's see if I can move it down the glare. So remember, no matter what the shape looks like, if it has a certain number of sides, it's going to be a certain shape. So I could have 1, 2, 3, 4, 5, 6, 7, 8. That's an 8-sided polygon. So that's going to be an octagon. Now the last one, and I certainly can't draw it to look like this, is a decagon. I'll write that over here. I want you to think to yourself, how many sides does a decagon have? 10. It has 10 sides. And like I said, I'm not even going to begin to draw it like this, so I'm just going to count my sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's kind of a funky looking decagon. So those are the names of the polygons. I'm going to review those in just a second. We have, let me put my camera back up. We have our triangle. Our triangle has 3 sides. We have our quadrilateral. It has 4. Pentagon. It has 5 sides. Hexagon. It has 6 sides. Octagon. It has 8 sides. And a decagon has 10 sides. It's just a matter of being able to remember those names. Remembering that hexagon is 6 sides, pentagon is 5 sides. So make sure you're practicing those so you understand them. The next thing that I'm going to teach is our last thing, and it is probably going to be the trickiest part of the lesson, because I'm sure you've heard all of these terms before. I'm sure you've heard hexagon, I'm sure you've heard quadrilateral, but these are terms that you may have not heard before. We're going to talk about convex and concave polygons. And I told you a while ago to store the term diagonal. Remember, diagonal is when you're connecting vertices. So, I want us to think about this. I'm going to draw this shape right here. Let me fix that. This is why I am not an art teacher. Alright, I have that polygon here. Let me count my sides. 1, 2, 3, 4, 5, 6. Think to yourself, what shape, what polygon is it? That's right, hexagon. I'm going to start drawing the diagonals here. Here's a diagonal. Here's a diagonal. Here's a diagonal. Here's a diagonal. Oh, but look at this. Here's my vertex right here. I'm going to put a dot on all my vertices so you can see. I'm going to put a dotted line between this vertex and this vertex. I want you to think about something for a second. This polygon has a diagonal that is outside of the shape. That is outside of the shape. So, this polygon is going to be a concave polygon. And the reason it makes it concave is because when you connect all the vertices, you're going to have one or more that are outside of the polygon. And that's what makes it concave. Think about this. You go into a dark cave, you see a bat. All you want to do is get out of the cave because you don't want to be there with the bat. So, out of the cave, concave, the vertex is out of the polygon. Now I mentioned a convex polygon. And it may make a little more sense once you see a convex polygon. I am going to do that. Think to yourself, what shape did I make? What shape? Count the sides, count the sides. That's right, pentagon. I'm going to start drawing my diagonals. Oops. Notice all of my diagonals are inside the polygon. So this makes this polygon convex. This is a convex polygon because all the diagonals are inside my polygon. Now, concave is where you have the one or more diagonals out of the polygon. Convex, all of the diagonals are inside. So that's just going to be a matter of understanding your diagonals and remembering which is which. When you come to a shape and it wants to know, is this convex, is this concave, draw your diagonals. If you have a scrap paper, draw the shape on your scrap paper and draw the diagonals. Figure out if one of your diagonals, if one or more of your diagonals is outside of the shape, it's going to be concave. Same thing, if you draw the shape and all of your diagonals are inside the polygon, it's going to be convex. So it's just a matter of remembering what convex, knowing that the diagonals are outside, and concave, convex, the diagonals are on the inside, and concave, you have one or more that could be on the outside. So practice those terms. Hopefully I can get a new program where the sound will match for my next video. If not, hopefully I will get it soon. But I at least wanted to put a video so at least you could listen, if anything. Have a good night.